In this illustration, we are given two tracks, each of mass capital M, are moving without friction in opposite direction on the adjacent parallel track with the same speed, same velocity u. You can observe here in this figure, this track number 1 is moving in the rightward direction with the speed u, it is having mass capital M. Track number 2 is also moving in this track, parallel track, with the same speed u, and it is also having mass capital M. One is carrying potato and other is carrying onion. Suppose this is carrying potato and this is carrying onion. A bag of the potato has mass m1 and a bag of the onion has mass m2 included in the masses of the track capital M. That means this m1 or m2 both are included in capital M, right? That means capital M is the mass of the track plus bag of the onion or potato, and similar statement for this also. In next part of the question, it is given when trucks get close to each other while passing, the drivers exchange a bag with the other one by throwing the other one. Find the final velocities of the truck after exchange of the bags. We need to calculate the velocity of the both trucks after exchanging the onion and potato bags. So let us make the diagram to the next page. This is the situation. Now let us analyze the forces, type of the forces acting on the system. It is given there is no friction anywhere. That means there is no external force acting on any of the track in the horizontal direction. That means both tracks moves without friction. There is no external force acting any of the track in the horizontal direction. That means the linear momentum of any of the track will be conserved and always conserved in the horizontal direction. Okay. Now let us analyze what happens when they exchange the bag. This is the situation when they are crossing each other. This is carrying potatoes and this is carrying onion. Say this track number 1 throw bag of the potato like this, and this track number 2 throw the bag of the onion, and it is entered in the track number 1. Okay, that means the potato bag is removed from the track number 1 and entered into track number 2. Similarly, onion bag is removed from track number 2 and entered to track number 1. Okay, we know the tracks are moving with the speed u and u. That means while throwing, the velocity of the potato bag should also u in the horizontal direction, because bags are thrown in the direction perpendicular to the track. That means the speed of the potato bag in the rightward direction should also be u. That means the linear momentum of the potato bag should be equal to m1 u in the rightward direction. That is the same direction as the trucks move. And here we can observe this onion bag is thrown from this track number 2 perpendicular to the track direction. That means the velocity of the onion bag should also same as the velocity of the track. It is moving in the leftward direction. That means the velocity of the onion bag should also be u in the leftward direction. Leftward direction, that is in the horizontal direction, leftward. That means the linear momentum of the onion bag should be equal to m2 multiplied by u in the leftward direction. If we consider track number 1, what is happening? m1 u linear momentum is subtracted in the rightward direction and included the m2 u in the leftward direction. So let us analyze the linear momentum conservation principle in the horizontal direction, right? So first let us analyze this track number 1, right? Initial linear momentum when potato bag was not thrown, that is equal to capital M multiplied by u. Now this one, that is m1 multiplied by u, linear momentum is subtracted in the same direction. So linear momentum left in the system is equal to capital M multiplied by u minus m1u, and included linear momentum is equal to minus m2u. So, linear momentum just before the process completed is equal to m capital Mu minus m1u minus m2u, and after the process the truck with the onion bag move in the rightward direction with the common velocity. Say common velocity is v1. So, the mass of this truck just after the process should be equal to capital M minus m1 and included mass is m2. So, mass of the system of first truck should be equal to capital M minus m1 plus m2, and linear momentum should be equal to multiplied by its velocity just after the process. From this equation we can find the velocity of the truck number 1 in the rightward direction. This is equal to capital M u minus m1u minus m2u divided by capital M minus m1 plus m2. Now, let us analyze truck number 2. Let us assume the leftward direction is positive direction. That means the initial linear momentum of the system, that is the truck number 2, is equal to capital M multiplied by u. The removed linear momentum in this direction is m2u, right? So, linear momentum left in this system is equal to capital M multiplied by u minus m2u, and included linear momentum is m1u. This is the potato bag, but in the opposite direction. So, linear momentum just before the process should be equal to capital M multiplied by u minus m2 multiplied by u minus m1 multiplied by u, right? And after the process, the truck and the potato bag both move with the common velocity. The mass of the system after the process should be equal to capital M minus m2, because m2 mass bag was removed. So, capital M minus m2 and m1 mass is included. So, capital M minus m2 plus m1, and let velocity of this truck is v2 after the process. So, linear momentum should be this one. From this equation we can find the velocity of the truck number 2 just after the process. This is equal to capital Mu minus m1u minus m2u divided by capital M minus m2 plus m1.
Dear aspirants, Cengage India has launched the new edition of our JEE Advanced Physics books. Please visit www.cengage.co.in to buy a copy. You can also buy the books from Amazon or Flipkart.